Hello children, how are you all? I hope you are enjoying the topic of sets. So in this series today we will discuss about Venn diagrams and their importance, various operations that can be performed on sets, and the properties related to these operations. So first let us understand what is a Venn diagram. You know that pictorial representation of any concept makes it easier to understand. So this is what a Venn diagram does, especially when we are dealing with many sets in a particular situation. Here we make use of rectangles, circles and other closed curves to represent various sets, and the elements of these sets are written inside these curves. The universal set is usually denoted by a rectangle in a given situation. Like if we have a set of natural numbers from 1 to 10, and a subset of this containing even numbers, then we may use the following Venn diagram to represent the situation. So U is the universal set containing natural numbers from 1 to 10. Showing the circle inside the rectangle means that A is a subset of U. Using Venn diagram is going to be a real fun. Now just as we use addition, multiplication and other mathematical operations on numbers, and we obtain a new number as a result, similarly we can perform certain operations on two sets to obtain another set. So the first operation we will learn today is union of sets. As the name suggests, we have to combine two sets together. So if A and B are any two sets, then the union of A and B is the set which contains all the elements of A as well as B. Take care that if any element is present in both the sets, then we will write it only once in the new set. Symbolically, union is written as this and read as A union B. Children, don't confuse it with the letter U. So A union B is the set of all x such that x belongs to A and x belongs to B. For example, if we have two sets A equal to 1, 2, 3, 4, 5, 6 and B equal to 2, 4, 6, 8, then to find the set A union B, I will first write all the elements of A and then I'll write those elements of B which are not present in A. So we get this. In order to represent them in a Venn diagram, we can consider a universal set U. As A and B have some common elements, so we will show them by two intersecting circles. The region which is included in both the circles denotes the common elements. Now to represent A union B, we will shade both the circles because the elements of both the circles are included in the union. So are both the methods of representing union clear to you? Let us discuss some properties of this operation of union. You can relate some of them to the properties of addition and multiplication of numbers. Like first one is commutative law, which says A union B is equal to B union A. Second one is associative law, which says that we can take the union of any two sets first and then the union of the resulting set with the third one. The third property is very obvious as phi has no elements in it, and so we can also conclude that phi is the identity element of union. Do you remember that identity element is that which does not change the value of the other number on performing a particular operation with two numbers? The same concept applies here. This is called the law of identity element. The fourth law says that A union A is equal to A. This is called idempotent law. Fifth one is U union A equal to U, which is obvious as A is a subset of the universal set. You can easily verify all these laws using different examples. Now we come to the second operation, which is called intersection of sets. It gives us the common elements of the two sets. So intersection of sets A and B is the set of all the elements which belong to both A and B. The symbol used for this is this, and we read it as A intersection B. So A intersection B is the set of all x such that x belongs to A and x belongs to B. In the previous example, A intersection B is equal to 2, 4, 6. And pictorially we can represent it by the following Venn diagram. Here we have shaded the common area to represent A intersection B. Is this operation clear to you? Now let's discuss the properties related to intersection. The commutative and associative laws hold true in intersection also. Phi intersection A is equal to phi as no common element is present in the two sets. As A is a subset of A intersection A will be equal to A. Similarly, U intersection A is equal to A itself. The most important property of intersection is that it is distributive over union. So we have the last law, A intersection B union C is equal to A intersection B union A intersection C. The next operation is difference of sets. Difference of sets A and B is the set of elements of A which do not belong to B. We use the symbol of subtraction for representing this. So A minus B is set of all x such that x belongs to A and x does not belong to B. Just like normal subtraction, we have to consider the order of sets in this. What I mean to say is that A minus B and B minus A are not same. B minus A is set of all x such that x belongs to B and x does not belong to A. Like in the above example, A minus B will be 1, 3, 5. To represent this operation as a Venn diagram, we will shade the region of circle A which is not common to the circle B. Similarly, if we calculate B minus A, it will be containing only element 8. So in the Venn diagram, we will shade the uncommon portion of B. Are all these operations clear to you? We will practice all these in exercise 1.4, but before that I want to introduce one more term of set theory to you, that is called disjoint set. Two sets are said to be disjoint if they have no common elements. In other words, if A intersection B is equal to phi. So can we say that A minus B and B minus A are disjoint? Yes, surely. Now let us start the exercise. In the first question, we are asked to find the union of the given sets. To find the union, we have to write all the elements of the first set and then the elements of the second set which are not present in the first one. So you can easily do the first two parts. As the order of element does not matter, you may write in any order. In the next two parts, the sets are given in set builder form. So let us convert it into roster form in order to know what are the elements present in these sets. A is a natural number and multiple of 3, so it will be 3, 6, dash dash dash, and B contains natural numbers less than 6, so we have. But if we combine these two sets, we will get numbers which are not following any particular pattern. So we cannot write this answer in roster form. So A union B can be written as set of all x such that x is a multiple of 3 or x is equal to 1, 2, 4, 5. In the fourth part, A contains natural numbers from 2 to 6 and B contains natural numbers from 7 to 9. So the union of the sets can be written by writing the elements of A followed by the new elements present in B. And we get 2, 3, 4, 5, 6, 7, 8, 9. So are these two answers clear to you? Fifth one is simple. As phi does not have any element, so obviously A union B will be equal to the set A itself. Question 5 is related to question 1. So we will first complete question 5. Now we have to find the intersection of the same sets. In intersection, we have to write the common element of both the sets. So clearly x intersection y is equal to the set containing 1 and 3. In the second part, A intersection B will contain only element A. In the third part, from the roster form, we can see that the only element which is present in both the sets is 3. So A intersection B is the set containing 3. Which element is common in the fourth part? There is no such element. So A intersection B is the empty set phi. In the fifth part, as one of the sets is phi, A intersection B will be equal to phi. Now question number 2. Is A a subset of B? Yes, it is. So what should be A union B? Whenever one set is a subset of other, then the other or the bigger set would be the union. So A union B here is equal to B. Similarly, in question 3, you are given that A is a subset of B. It means A union B is equal to B. Now in question 4, we are given 4 different sets and we have to find out various answers. Please complete the first 4 parts. I'll discuss the remaining 3 parts. In order to find A union B union C, we can use the associative law and write this as A union B whole union C. So first let us write down the union of A and B, which comes out to be 1, 2, 3, 4, 5, 6. Now you can easily take the union of these 2 sets and finally we have this as the answer. Is it clear? Same way in the 6th part, A union B union D will be equal to this set union this set. And on taking all the elements of these 2 sets, we get the set containing numbers from 1 to 10. Now in this one, we will first find out B union C and then take the union with the set D. So B union C contains the numbers 3, 4, 5, 6, 7, 8. The only numbers which are remaining in set D are 9 and 10. So the union of all these 3 sets contains the numbers from 3 to 10. So I hope children this is clear how we have used here associative property to find the union of 3 sets. Now in question 6, you have to find the intersection of sets. In intersection, we have to write the common element of both the sets. So A intersection B is the set containing 7, 9 and 11. Similarly, if we take intersection of B and C, the common elements here are 11 and 13. To find the intersection of 3 sets, we will again use associative property of intersection. So we will write it as A intersection C whole intersection D. Which elements come in A intersection C? Only 11. So when we take the intersection of 11 with 15, 17, we don't get any common element and the answer is 5. In the 4th part, intersection of A and C is 11 as this is the only common element. B intersection D will be equal to 5 because you don't find any common elements in these 2 sets. Now A intersection B union C. We will have to follow the order if the brackets are already given. So first we will take B union C. And we get the numbers 7, 9, 11, 13, 15 in the union. Now if we take intersection of this set with the set A, we get the set 7, 9, 11. This question can also be solved by using the distributive property of intersection, according to which we will write this equal to A intersection B union A intersection C. A intersection B is 7, 9, 11. Intersection of A and C is 11. Now you can easily take the union of these two sets and we get the set 7, 9, 11. A intersection D is equal to 5. Now A intersection D union D will be equal to A intersection B union A intersection D. A intersection B contains only 3 elements, whereas A intersection D is equal to 5. So union of these two sets is 7, 9, 11. Now the ninth part. What are the common elements of A intersection B? Yes, they are 7, 9 and 11. In B union C, we have 5 elements, 7, 9, 11, 13 and 15. Now if we take the intersection of these two sets, we get 7, 9, 11. Are these steps clear to you? If you have any question, you can ask in the comment box. In the 10th part, let us find out the unions of the two sets given in the brackets first. So first one gives us this set and the second one gives us the set 7, 9, 11, 13, 15. Now you can see that we have 4 common elements here. So the intersection of these two sets gives us the set 7, 9, 11, 15. Now 7th question is also similar, but we have set builder form given here. So we will first have to find out the roster form and then we can easily find the answers of all these questions. So please try these and then you can cross-check your answers. In question 8, we have to find out whether these sets are disjoint or not. It means that whether they have a common element or not. So let's convert the various set builder forms into roster forms. So the intersection of these two sets contains an element 4. Hence this pair is not disjoint. You can clearly see that in the second part E is a common element. Even if one element is common, the sets are not disjoint. In the third part, the numbers 2, 4, 6, etc. belong to the first set, while the second set has numbers 1, 3, 5, etc. So clearly intersection of these two sets gives us the set 5. So this pair is disjoint. Now let's start question 9 based on difference. As I discussed earlier, whenever we are finding difference, we have to concentrate on the first set. So A minus B means we will only take the elements of set A which are not present in B. So what are the common elements of these two sets? Only 12. Therefore A minus B is equal to 3, 6, 9, 15, 18, 21. A minus C means we have to write the elements of A which are not present in C. Which elements of A are present in C? They are 6 and 12. So A minus C is equal to this. Now A minus D means we have to leave those elements of A which are present in D, and there is only one such element, that is 15. B minus A means we have to leave those elements of B which are present in A, and that is only 12. So B minus A is 4, 8, 16, 20. So now please try the remaining answers, and if you have any problem, you can cross-check with my solutions. Now question 10. X minus Y means we have to leave all the elements of X which are present in Y. There are two elements of X present in Y, that are B and D. So X minus Y is the set containing elements A and C. Y minus x means we have to leave those elements of y which are present in x. So we get y minus x equal to f comma g. X intersection y is equal to the common elements of both the sets, which is b and d. So if you look at these three answers, you can clearly understand that x minus y, y minus x and x intersection y are three different operations. In question 11, we have to find out r minus q. We know that r is set of real numbers and q is set of rational numbers. So which numbers are left if we remove all the rational numbers from the set R? They are called irrational numbers. So R minus Q is the set of irrational numbers. Now tell which of the following statements are true, and if you find that some of them are false, then you have to give a justification. That means you have to give at least one example which justifies your answer. In first part, you can easily see that 3 is a common element of both the sets, so their intersection is not phi, and hence this statement is false. Similarly, the second one is also false because the intersection of these sets contains the element A. In the third part, we don't have any common elements in both the sets, so it is a true statement. Fourth part is also true as the intersection of these two sets is phi. Children, with this we come to the end of this video. Hope you enjoyed this session. We will meet again soon with another session on sets. If you have any queries, please leave your question in the comment box. Take care and goodbye.